Hello geographers and welcome to today's lesson about waves. My name is Mrs Marshall and it's a pleasure to teach you today. I grew up in Weymouth, which has a great beach, so I love taking any opportunity to head down there like I did this morning. It was obviously a vital trip if we're going to be learning about waves today. For today's lesson, all you need is pen and paper. Please pause in a second and take a moment to get them and to clear away any distractions around you. Alternatively, you might choose to move to a quiet place where you won't be disturbed during the lesson. Right, now you're ready to start, let's dip our toes in the water. The first thing we're going to look at today is how do waves form? Waves form as a result of wind blowing over the surface of the sea. Friction causes that top layer of water to be dragged along, creating the wave. You can have a go at this after the video down in your kitchen. If you get a saucer of water and fill it with water and then blow gently, you will see that you're able to create your own waves as that friction drags along and creates the ripples. There are three things that determine the size of a wave and its wave energy. How strong the wind is, how long the wind has been blowing for, and how far the wave has travelled. Geographers like to refer to this as fetch. If we think about Cornwall, Cornwall has a wind coming from the southwest as the prevailing wind, the most frequent. And that wind blows all the way from the Americas across the Atlantic Ocean to Cornwall. Therefore, it has a very large fetch, which means the waves are often much larger because they've been able to build up over a larger distance. If we think about Bournemouth, which is just the other side of the English Channel to France, the distance of open water is much smaller. Therefore, the waves haven't had the same distance over which to build up. So waves form by wind blowing over the surface of the sea. Their size and energy can be determined by how strong the wind is, how far the wind has travelled, and how long the wind has been blowing. It's your turn now, so which three of the statements below are true about waves? So grab your pen, I'm going to give you about 10 seconds to do that. So you should now have three letters written down. Which ones are true? I'm hoping you got B, C, and D. So the incorrect answer was A. Waves are not formed by the moon's gravitational pull. The moon's gravitational pull actually helps us create tides. And it's a common misconception people get mixed up. So make sure you got that clear. Just jot it down if you need to. What do waves do when they break on our shore? The first thing they do is the waves wash up the beach. And the word sounds very much like the noise of those waves. So as you hear those waves come up, they make the noise swash. And the word swash means the waves moving up the beach. You'll see that swash is there at an angle, and that angle is determined by the wind direction at any given time. So the wind blows the water up the beach at an angle. The water then has to go back down to sea, and we call that backwash. You'll notice the direction of that arrow is directly vertical, so it goes down the beach at a 90-degree angle. And that is linked to gravity. If I took my bottle of water and tipped it upside down now, it's going to go straight down. Gravity is going to pull that in a vertical line. I might make a mess in my office as well, so maybe I'll leave that one. Let's have a look at that. So as I said this morning, I went out and I filmed the beach near me. I also got very wet when I was filming because I didn't notice the very large wave approaching since I was looking the other way, but we live and learn. So as you watch this video clip, I'm asking you to look for swash, which goes up the beach at an angle. There was a southwesterly wind when I went. And backwash, I want you to look at the water going vertically back down afterwards. We're going to watch the video through twice. So swash up at an angle and then backwash. You can see the bubbles going back down. One final time. So swash and then backwash straight back down. So your turn. Swash is option 1 or option 2. 5 seconds. Okay, did you get it? Swash is option 2. The movement of water as it rushes up the beach from the sea at an angle. Tell me quickly, what makes that angle? Yes, wind direction. Well done. The direction of backwash is determined by option 1, gravity, option 2, wind direction. 3, 2, 1, and it is gravity. So the direction of backwash is always at 90 degrees to the beach as a result of gravity. So your first task is coming up. Should be a super easy one for you now because you've answered those questions so nicely. I would like you to copy and label the diagram below. To do that, I would like you to make sure you have labelled beach, sea, swash, backwash, wind direction, and 90 degrees. So it's time for you now to pause the video. Please remember to draw the diagram with a pencil, and please remember to press resume on the video when you are done. Welcome back. Your diagrams look very neat. Well done. So you should have, give them a tick, beach, sea, swash, and it's really important you've got that angle on swash. Backwash, make sure it goes straight back down your page. You've got that wind direction, and that should be the same angle as swash. So just have another go if you need to tweak it slightly. And then 90 degrees on that backwash arrow to help you remember. Next is, what are the 2 types of waves? 2 waves on the screen here. Constructive waves. They look much smaller. They look quite pleasant. The destructive waves look very, very large. Think about the last time you went to the beach. What would you have said the waves were? Constructive or destructive? Those 2 waves are different. They have different characteristics. So let's try and unpick that a little bit. So constructive waves. Constructive has got the start of that word construct in it. At a construction site, we would find people building. A construction site is a building site. If you construct something at home, you are building it. So these waves work the same way. They build the beach. And to do that, they need a very large swash. You can think about these waves as being a big bulldozer. As they go up the beach, as the swash, they scoop up and push all the sand up onto the beach. They have a very weak backwash. So they've pushed all the sand up and then they don't take any away with it. These waves, as we saw in the picture, have a low wave height. And you can see my black arrow there from the wave trough, so the bottom of the wave, all the way up to the wave crest, the top of the wave. They are very low waves. However, they have a very long wave length, and that's the distance from crest to crest. So these waves come into the coast further apart. Constructive waves cause deposition. They construct a beach. They are mainly occurring during the summer, and they have a low frequency. So they arrive about 8 to 10 per minute, and that's linked up to the fact they have a longer wavelength. Destructive waves are the opposite. We've got the word in there now, destroy, destruct. If you destroy something, you break it down, and these waves will break away the beach. To do that, they have a weak swash, but their backwash is incredibly strong. So as that wave plunges, as that wave breaks, it scours into the beach and like a digger bucket really scoops up the sand and takes it back into the sea. Compared to constructive waves, they are much taller. They have a high wave height. Their wavelength is shorter. They erode, they destroy the coast. They are common in winter. And they have a higher frequency of about 10 to 14 waves per minute. Your turn. Which two are characteristics of destructive waves? You've got 4 options. A, they do have a short wavelength and they erode the beach. So C and D are the incorrect answers, but let's see if you can help me turn those into correct characteristics for a destructive wave. Destructive waves have what type of swash? A weak swash, well done. But their backwash is strong. You've got it, well done. The best thing about being a geography teacher is that ability to be able to go out and enjoy field work like I did this morning. We're going to watch a video clip I took, and I would like you to help me decide whether this morning there were constructive waves or destructive waves. To do that, I would like you to consider in the video the wave's height. I would like you to consider the wave length, and I would like you to count how many waves appear so you can comment on the frequency. A little bit of a hint is that this video clip is 20 seconds long. I gave you the wave frequencies per minute. For constructive waves, it was between 8 and 10 waves per minute. And for destructive waves, it was between 10 to 14. But we've only got 20 seconds. So to turn that 20 seconds into a minute, we need to multiply it by 3. So 3 lots of 20 seconds would be a minute. So you're going to count the waves, and then we're going to multiply it by 3 to see whether we can work out whether they are constructive or destructive waves. So first wave is in, 1. Right, there we go. So how many did you get? Hold your fingers up for me. Yeah, there were 5 waves. So we have to do that maths. 5 waves in 20 seconds is 10 waves in 40 seconds. So 15 waves in 60 seconds. The waves this morning had a high frequency, 15 waves in a minute. So that means the wave is, tell the screen now. You got it. The waves this morning were destructive. They had a high frequency, they looked tall, and they came in quite close together, so their wavelength was short. It's down to you. On the board, we have got 6 statements. I would like you to write down whether you think they are true or whether you think they are false. I would like you to pause the video to complete your task and then resume once you are finished, and we'll join each other again for the answers. Off you go. How did you get on? Hopefully, have a look down. You should have found 2 false answers. Answer number 1 was false. That is not a constructive wave. It's very tall, so therefore it is a destructive wave. Just jot down the correct answers. Destructive waves do not have a low frequency. They have a high frequency. We've just counted them, between 10 and 14 waves per minute. The rest of the 4 statements were true. How did you get on? Let's summarise it all, because we've learned a lot of characteristics. I've got on the screen the constructive wave characteristics. I would like you now, while I pause, just to go down the destructive waves and say out loud the opposite. The more we think hard about this, the better the chance it has of being ingrained in our long-term memory. So I'll do the first one for you. Constructive waves have a strong swash, whereas destructive waves have a weak swash. Off you go. 5 seconds for you to do the rest. Let's see how you got on. In an exam, we're assessed on these by being asked to contrast the different wave types. To contrast, we're looking for differences. So if we have a look at this statement below, constructive waves have a strong swash, whereas, and that connective signifies that we're looking at differences. Destructive waves have a, tell me now? Yes, a weak swash. So that statement shows contrast. It's your turn now to have a go. So your main task today is to contrast the characteristics of constructive and destructive waves. You are looking for the differences. The question would be allocated 3 marks. So that means I would like you to write down 3 different characteristics. I've just modelled swash, so I'd really like you to challenge yourself and use different characteristics. In your writing, and make sure you highlight these so you can see them and check you've done it correctly, we're using connectives that show contrast. You could use however, on the other hand, and in contrast. So pause the video, join me again when you're done. Best of luck, you can do this. How did you get on? I think you will have done excellently. We had to contrast the characteristics of constructive and destructive waves. Constructive waves have a weak backwash, whereas destructive waves have a strong backwash. Give yourself a tick if you talked about backwash. Constructive waves are low in contrast to taller destructive waves. Constructive waves cause deposition, while destructive waves erode the coast. So hopefully you got 3 marks there. You've done really, really well this lesson. Well done. Well, that's it for today's lesson. We've learned about waves, how they form, and the difference between constructive and destructive waves together today. Congratulations on the splashtastic learning you've constructed. But there is one final task before you disappear. I need you to click on the next page and complete your quiz to show me just how much you've learned. I'm expecting great things. Thanks very much for your time today. Take care, and I look forward to you joining me to look at coastal erosion processes soon. Have a great day.